Hello, everybody. Thank you for coming to my talk. And today I'm going to be talking about getting started with GraphQL in an enterprise. My name is Shruti Kapoor, and I wish you a very happy Women's Day. So, in this talk, I will be talking about the following things. I'll start with what is GraphQL, who is using GraphQL, and why you should even care about this technology. I'll talk about our story of adopting GraphQL in enterprise. And then I'll talk about the lessons that I learned, the mistakes we made, the things we could have done better. And if you are interested, how you can get started in your enterprise. So, first, I'll start with an introduction of myself. My name is Shruti Kapoor. I am a senior software engineer at PayPal. I've been working as a software engineer for the last 7 years. I love JavaScript and GraphQL and React and front-end technologies. I share a lot of GraphQL tips on my Twitter account, ShrutiKapoor08, and I also send JavaScript newsletters at my newsletter, tinyletter.com/ShrutiKapoor, which is usually like 1 minute read of some JavaScript tidbits. So if you're interested, here is the links to sign up. Fun fact, I was working on this talk on my Twitch live stream where I set up like a 25-minute chill working session, play some music, and get some work done, side projects as well. So if you're interested, I would love to see you on Twitch and work together with you. So before we get into the story of how we started adopting GraphQL, I want to give a little bit of introduction about myself and my background. So I started working as a front-end engineer almost 5 years ago, and I started working with technologies like JavaScript and Graph and React and Redux, and I joined PayPal almost 3 years ago. And before joining PayPal, I had actually never heard of GraphQL. And I thought GraphQL was like this thing that Gatsby was using, and maybe it was similar to Graph in some way. But people told me it's not like D3JS. So I was pretty much very confused about GraphQL before coming to PayPal. When I came to PayPal, my task in this team was to work on this internal application. And basically, we were supposed to make this internal project that was supposed to be used by our customer representative folks. It was kind of like a servicing dashboard kind of thing. And from a technical architecture perspective, it was supposed to use 5 internal APIs. 4 of those APIs were already existing and they were used by the rest of the PayPal as well. One of those APIs we were supposed to develop, it was a REST API. At PayPal, most of our APIs at the time were REST APIs. In fact, all of our APIs at the time were REST APIs, and we were working on a Node.js app. So that was the state of the project that was when I joined in. State of GraphQL was also pretty new at the time. GraphQL was used by only one other team at PayPal, at least the one that I know of. There was no tooling regarding GraphQL at PayPal at the time. And even outside of the community in 2018, it was kind of slowly picking up. GraphQL had recently been open sourced in 2015, so it was like slowly picking up by companies like Apollo and Prisma and dgraph and Hasura. But since 2018, a lot has changed. Let's talk about what GraphQL is today. These are all the companies that are using GraphQL today. So if you look at the second column, second row, there's almost all big companies using GraphQL today, most of them publicly. So there's PayPal and Twitter and NBC and Pinterest and Facebook and Intuit and Yelp and Wayfair. GraphQL as a whole, as a community, has become a lot more stable. There's a lot more projects that are being worked on in GraphQL. There's a lot more services and a lot more companies that are investing their time and tooling into GraphQL. So as a community, it has become a lot stronger. And now we have the GraphQL Foundation that actually takes care of these open source projects as well. In terms of companies, it's actually being used by a lot of huge enterprises. For example, Netflix, Twitter, PayPal, and a lot of these companies are also now contributing back to GraphQL in the community. PayPal and Braintree are both using GraphQL. GitHub's GraphQL API is actually now public. In in terms of its GitHub project, GraphQL is actually a specification. So GraphQL is available in multiple different languages. So the language that I'm going to be talking about here is GraphQL JS. GraphQL JS has become really popular in the last 2 years. As you can see, there is 437K thousand users of GraphQL. 437K users of GraphQL, and it is being contributed by 165 people actively. Um, According to the survey of State of JS 2020, GraphQL was awarded the technology that got the highest interest from developers. Most of the developers want to start working with GraphQL in 2020. And at PayPal as well, we've been doing really well with GraphQL. In the last 2 years, we have now 33 apps that are in production using GraphQL. And Braintree, which is also a PayPal company, has its GraphQL API in the public. Our Slack community has grown from just 30 people to almost 500, to more than 500 people now. And as a PayPal, we've been putting out a lot of internal tools to stabilize the adoption of GraphQL and to make it a lot easier for our new teams to start using GraphQL. And PayPal has become an active member of GraphQL Foundation and has been putting a lot of resources and a lot of efforts in becoming an active community member by giving talks like this one, by going to the Start Contributor Days, by attending conferences and speaking at conferences like Apollo GraphQL Summit. There's also been a lot of tools that have come out in the last 2 years. I'll show you one tool, which is this graphical tool, which is actually my favorite tool. So the URL for this tool is graphql.org, and you can find the URL there, which is swappy-graphql, but I'll give you a quick demo here. So I'm going to copy this URL here, paste it in my browser, and basically when you open the URL, you will see this screen. So on the left side, there is kind of like this code editor. And on the right side, if you look, there is like this documentation explorer. So the first thing you'll see here is if you click on this documentation explorer, you'll see query. Don't worry about what our query is for now. We'll just open this. So already I can see like there are some operations available for me. And then if you look here, it says that you can type queries into the side of the screen. And basically what I'm going to do is I'm going to copy this here and paste it here, uncomment this, uncomment it manually. And so what this basically tells me is that this is the query I can fire. And on the right side, I have all the available queries to me. So I'm just going to scroll here and see anything that I like in particular. This is also, by the way, Star Wars inspired. So I'm going to look at this all planets, and looks like if I query all planets, then I can get a people connection. Planets connection. So I'm going to try that. So I'm going to query all planets. And already you can see, like, as I start typing, it shows me all planets already here. So it accepts an argument, and looks like I don't need to pass an argument in here. So I'm just gonna call for all planets, and then it says that you cannot query subfield, which makes sense because subfield is not the field. So I'm just going to look for planets, and then it pops up the documentation here. So it tells me like a list of all the objects returned. So it looks like I need to fetch something from planets. And for now, I'm just going to get the name. So there it is. So that looks like it's valid. There's no errors. I'm going to fire that. And already I have a list of some planets here. So that's cool. That was super fast. And let's say that I want something else. So I've got the name, but maybe I'm a super planet nerd and I want like all of these fancy diameters and rotation periods. So what I can do is I can just start typing all these things out. And rotation period, I'm going to get everything actually. There we go. I think that's enough. So I'm just going to fire that. And see, there you go. Super fast. I didn't have to do any integration. I didn't have to like open up my terminal or anything. Everything is here. I've got my code editor here, and I've got my documentation explorer here. So I went from like not knowing what this GraphQL query is about all the way to like finding all the data that I need. So that's really cool. And that's the best part about this tooling. And I think I feel like GraphQL is one of the tools that kind of like really inspires people to start using GraphQL. because it's so easy to see what resources are available, what information the API is sending, and kind of like start getting your hands dirty right away. So that's graphical. There's also amazing tools that are already out there, such as GraphQL Editor, GraphQL Playground, and there's a bunch more: Express GraphQL, Apollo, Prisma, Sora, dgraph. But if you're in the audience thinking about like, what is this GraphQL? I have no idea. This is the first time I'm hearing about it. Is it like graph or what? Don't worry, I got you. So I'll talk about what is GraphQL. So this will be a brief introduction of what is GraphQL. So GraphQL, as the name kind of suggests, is a combination of graph and QL. So the graph in GraphQL represents the structure of data. So you kind of think of how a node or like how a field is connected to another field. So the fields are kind of connected as a graph. The data type doesn't have to be a graph, but it's just like how a planet may be connected to its name, and name may be a string. So how is one field connected to another field? That's what the graph represents. And QL stands for query language, and it's a way of querying an API. It doesn't mean SQL like technology. You don't have to fire like select star everything. It's just a way of querying for APIs. So in short, GraphQL is a query language for APIs. In fact, the official definition is also that GraphQL is a query language for APIs and a runtime for fulfilling those queries with the existing data. GraphQL provides a complete and understandable description of the data in your API, gives clients the power to ask for exactly what they need and nothing more, and makes it easier to evolve APIs over time and enables powerful developer tools. But I think of the sentence, the most important part for me was that GraphQL gives clients the power to ask for exactly what they need and nothing more. And as a front-end developer, this was really powerful because I didn't have to worry anymore about what data was coming back from my REST API or from my API, because I was getting back only the data that I asked for. So I'll explain how working with GraphQL works. So let's take a look at fetching maybe like a REST API. So let's say that this is on our PayPal dashboard, and what we want to do is we want to show the username. We want to show maybe like the balance, and then we want to show maybe if they have received any notifications. So what we'll do is that, let's say that we got an endpoint customer/account. That is the account, that is the endpoint that gives us how much balance they have. So let's say that that is the endpoint that I want to fetch. So I've got that endpoint, but actually to fetch that endpoint, I actually need to know who the user is. So I need to call auth. But then at the same time, when I call auth, I need the ID of that user. So I might need to use an endpoint like user/ID. Then I have to send that over to maybe another endpoint like account details to get their name and their username and their first name and last name and shipping address and whatnot. And then I will probably have another endpoint to call notifications. So to get one endpoint, I probably have to make a bunch of other calls as well, like to get the auth, to get the user ID, to get the account details for their balance and this and that. So in fact, to call account, I'll have to first call auth, then I'll have to call these other APIs. And then once they resolve, once they give me my data back, I can then send it over to customer's account, and then I get all of the data that I need back to my client. So that's how working with REST works. But with GraphQL, what we can do is there's only one endpoint. There's only paypal.com/GraphQL. So all the data that I need, I have to get it from the same endpoint. Then I send it over to my endpoint, and then the endpoint does the job of like figuring out what API endpoints it needs to call. So as a client, I'm only seeing one endpoint. So I send that data over to my GraphQL endpoint. It does its magic and then comes back and gives me the data. And then the data that it gives back is the data that I send over to my client. So I don't have to do any other magic. Now, before we dive any further, let's talk about some GraphQL terminologies. So in GraphQL, there's 4 major terminologies. There's the schema, queries, mutations, and resolvers. So schema, let's talk about schema first. So schema is kind of like a contract that defines exactly the type of data and a complete set of data that is available. So this will be a complete list. This is the only data that the service will give back. So it has to be an extensive list. For example, I'll show you here. Let's say that we have a type character, and we define that the character can only have two fields, name and appears in. Not only does it define what the fields this type would have, but it also defines what the data type of that field would be. So name can only be string, and the exclamation mark represents that it's a required field. So right away we have to tell GraphQL what fields we can expect in this type and what is the data type. Same with Starship. So that's schema. It's kind of like a contract. It's kind of like a complete list of all the data types that you can expect this API to give back to you. And then we have query. So if you see here, this might seem familiar to Jason. So basically you have like an object and you're getting the name out of that object. And then you have another object, for example, another field like droid, and you're getting the name of that field as well. So you're going to send it over to your GraphQL API endpoint, and it gives you back a data back, which kind of looks like JSON as well. So you asked for hero and its name, so you only get the name back. Then you ask for droid's name, and you only get the name back. So basically, you're only getting the information that you asked for. That's the query. So if you draw a comparison between GraphQL and REST, query kind of looks like get, and then the mutation looks like post and delete. It's pretty much the same thing, except it helps you do the functions of put, post, delete as well. So you can pass arguments. You can modify the data on the backend side. Now, all of the heavy lifting is done by resolvers. And a resolver is basically a function that tells GraphQL API what that magic should be. So when you fire an API and you say, give me name, resolver is the function that tells GraphQL API what data to send back when the field name is asked. And that's why every field has a resolver. And that's actually what makes GraphQL really powerful. I'll show you an example. So let's say we have a type user, and we have a few fields defined here, like given name and family name and addresses. We will have a resolver for every single field. So we'll have a resolver for given name, which could be as simple as just give back the given name. And then we'll have a resolver for family name, and we'll have a resolver for addresses. So your resolvers can be as simple or as complex as you want. And this is really cool because you can put instrumentation right here, and you can get analytics for exactly which field was called how many times. So in short, GraphQL is an open source specification. It's not implemented in a particular language. The libraries have picked up that specification and implemented in a language of their choice. So there's GraphQL implementation in Java and JavaScript and Go and so on. And one of the most powerful features of GraphQL is the ability for a client to ask for exactly what they need and nothing more. And that's really powerful to me as a front-end developer, because I don't have to worry about all the garbage data that my REST API or like my API would be sending to me. So I can only ask for the data that I need, and I don't have to manage that data on my client end side. And that kind of reduces the need for external state management libraries. And that's even more powerful because I asked for a specific set of data for a specific structure of data, and then that's the structure I'm going to get back. So then I don't have to do any cleaning or filtering of data on the client side. So as a whole, it reduces a lot of work that has to be done on the client side. And another cool feature about GraphQL is that there's no versioning. So there's only the endpoint GraphQL. You never do like V1 or V2. And that's really cool because as a backend developer, now I can push updates whenever I need to. And as a client, I don't need to like continue to reintegrate with the API to get the new features. The features are out there in the schema, and I can just query for them whenever I'm ready. And same way, when I am ready to remove, or when I want to remove a field as a backend developer, I can look at my resolver, I can look at my instrumentation and see if that field is being used anywhere, and I can remove it when I'm ready. Another cool feature about the schema is that because we have to set up schema upfront, it kind of helps to establish as a contract between front-end teams and back-end teams. So now the front-end and back-end teams can kind of like start working together on the set rules, on the set contracts, and then go in their independent directions to implement that contract. And like I showed you, like the developer tooling around GraphQL has become really cool, and it's becoming really powerful, and it helps in getting new people onboarded onto the team, and helping to ease that learning process on getting GraphQL adopted, and explorability of APIs. So that's a one-on-one of GraphQL. Let's talk about some reasons to adopt GraphQL. So when we started looking at GraphQL, when we started looking at how our products were built, we realized that we were looking at products in terms of the data that we need, or in terms of like the fields that we want to query. So we were looking at this like notification banner, or like the user profile banner, and we were looking at the fields that we want to query from our API. So we were looking at, like, let's say, name and profile picture and the account balance. We were thinking of like what fields we need. So we naturally, as developers, think of data in terms of fields and not endpoints. So we won't be saying oh, I need the username, so I have to do a get here. We think of like what field we need, not like what endpoints we need, not like what not like joins that we're going to have to do on our endpoints. So that's already like one good thing about GraphQL, that it's very natural to the way we think as developers. And then another thing about implementation is in REST is, let's say that we've got a stable release out there. It's really great. It's working. It's working perfectly. Let's say we have 5 endpoints. But what happens when we have a new requirement? What happens when we want to add something? There's usually 2 options. One of them is that we can add a new endpoint. Let's say we have users, we can add another endpoint / account. But the problem is that it may cause the client to fetch multiple endpoints, like we saw in the beginning. So there might be a problem with performance because we may have to do multiple round trips. Another thing we could do is that we can add that information to the existing endpoint that the client has already integrated with. But the problem with that is that it serves one client, but then all clients have to pay the cost for it. They have this additional data that's coming in that they don't need. And that's why GraphQL was really cool for us, because we had one endpoint, so we could push out updates as soon as we want, and we can deprecate fields knowing whether or not that field was being used. So we weren't just like blindly removing fields. And then because the clients now were able to control what data was coming to them, so we were delivering less payloads to the clients. And as a developer as well, this was really cool, because when we had new people come on board, we would give them the graphical interface, and they would start exploring the API on their own, and they would automatically see what data is coming back. So it became very easy for them to kind of get familiarized with the APIs as well that we already had. And it brought our front end and back end teams a lot closer, because we started talking about about the data and the contract in the beginning itself. And then our teams were able to work independently from the contract that we established. So now that you have, now that we talked about like some good things about GraphQL, let's talk about how we want to incrementally start adopting GraphQL in an enterprise. So usually there's 3 approaches of adopting GraphQL. The first is to GraphQL all the things. So basically what you can do is you can pick your REST APIs and start adding GraphQL wrappers around them. That's usually called the orchestration layer. So you pick your REST APIs and you add a GraphQL wrapper. So the client sees GraphQL, but underneath it's all REST. The second is to add a REST wrapper around GraphQL API. And that's what GitHub was doing as well for some time. So basically you have like one implementation of GraphQL throughout, and then whoever wants to use REST can have this REST wrapper, which is actually GraphQL underneath. And then another approach is to have GraphQL and REST coexist. So all of your new implementations, new APIs are in GraphQL, and all of your existing APIs are in REST. And that's useful because you're not breaking implementation of current integrations, whereas all of your new implementations can now start using GraphQL. So basically 3 approaches. One is to orchestrate REST APIs as GraphQL APIs. Second is to keep your GraphQL API implementations and surface REST APIs only for the ones that need it. And the third is to have GraphQL and REST coexist at the same time. So Now let's talk about how we started fitting GraphQL in our enterprise, which is PayPal. So when we started looking at GraphQL and how it could fit us, we were basically working on this. I was basically working on this new team that was kind of like our first app, so to say. Our main goals for this project was to make the app fast. So we wanted to make increase the performance, and we looked at our app and thought about and explored how we can do that. And there were basically two themes that came up. One was that we should send less code to the client, and then the second was that we should send less data to the client. By sending less code, I mean sending less libraries. So we shouldn't add any libraries that we don't need. So we should keep the app as light as possible. And the second was to send as little data to the client as possible, so the client doesn't have to manage a lot of data. In PayPal itself, when we were exploring GraphQL, there were two main questions we were asking. We were checking, we were looking at what was the best way to build apps in 2018. And the second thing we were looking at, what are the current challenges that we have at PayPal? So we found out that the biggest challenge that our applications were seeing and developers were seeing at the time were performance. We were just sending a lot of data. We had too many endpoints. It was all quite populated. We had too many existing implementations, and we were never deprecating our content. And our developer experience kind of sucked because we had so many endpoints. So developers spent so much time looking at which endpoint to integrate with and what endpoint uses what information. So the explorability of APIs kind of took a lot of time, and made it really hard to work on the engineering aspect of building a great UI. Instead, we were spending a lot of time in finding out and exploring the API. So for us, the two main challenges that we were facing at the time was performance of the apps. We were sending too much data. And the second was just building the app took a lot of time because we had so many different APIs. So that kind of made us feel that GraphQL would be a really good option for this. We started looking at how we could use our existing APIs to kind of convert them into GraphQL. And we were thinking could be three ways. The first one is that we can convert an existing API into a GraphQL. We can build standalone APIs, which would be GraphQL, or we can, instead of like converting the APIs or like building anything, we can just like wrap it around GraphQL and the client would see GraphQL, whereas underneath it is REST. And the third approach worked really well because it did not mean that we had to take down any APIs. Anything that was existing already stayed up, and nobody had to integrate anything from scratch. So we picked our first app, the first app that would be GraphQL app. And the technology of that app was that it was this app that was already using 5 other existing REST APIs. One of the REST APIs we were building in-house. It was in our team, so we had complete control over it. And so what we decided to do was we kept 4 APIs that were already existing as is, and then the one API that we were building in our team, we orchestrated that as a GraphQL API. So we kind of did like this mapping of this REST API would become a GraphQL API, and then we'll have 4 other APIs. So we kind of had a combination of 4 REST APIs plus 1 GraphQL API that was talking to one REST API. And the reason we did that was because we had complete control over our REST API, so we could take care of our REST API and the GraphQL API at the same time, but also our GraphQL and REST APIs. Our GraphQL API could be dominated by the needs of the UI that we were building. So we got together with our backend developers and we started talking about the schema and the needs of the UI, and we set our contract in the beginning, and then we went and built our APIs in parallel. And after we built this, we found that GraphQL helped us because we were sending less data to the client, so it helped us in our performances. We don't have to do any more cleanup of the data or any more like structuring of the data on the client side. And now, with the help of graphical and all the tools that GraphQL provides, we were able to look at our documentation right away using the help of graphical and playground tools. So exploring APIs became a lot easier. So we were spending much less time looking at like what and endpoints we need to use, and we were spending a lot more time thinking about how we're going to use that data and focusing our time on building the UI. And so once we finished that little first app, we thought that we should convert all the GraphQL endpoints into all the REST endpoints into GraphQL endpoints, so we can reap the benefits all the way through the stack. But that wasn't quite possible because we had so many different downstream APIs, and it wasn't quite possible to pause all the development and like start converting all the REST APIs into GraphQL endpoints. So what we ended up doing was our applications now have kind of like this fragmented approach that some apps would have some REST endpoints, some may have orchestrated them as GraphQL, and some may have built a completely new GraphQL endpoints. But as a company, we're seeing some challenges in that approach as well, because since we have all of our different GraphQL endpoints in multiple teams, a lot of our teams are now having to fetch duplicate information because we have all these endpoints again. So we are moving to kind of like this federated graph approach, which is one graph, one endpoint to fetch all of that information. So in a nutshell, there's been two major apps that were kind of pioneer in this adoption of GraphQL. The first one was the checkout app, and the second one was the merchant app. And so in the checkout app, our major approach was to make this one GraphQL API that would have existing REST APIs. Plus anything new would be part of like this GraphQL API. So we had everything existing state as is, and anything new became part of a GraphQL API. Whereas in the merchants app, we kind of did something different. Because we were creating a new REST API, we orchestrated that as a GraphQL API. So what we found out was that the orchestration of REST APIs as a GraphQL API worked really well, because GraphQL works amazing as an orchestration layer. We were able to reap all of the benefits of GraphQL. Any extra data wasn't getting sent through because client wouldn't ask. So even if the downstream was REST, that's still okay because our client only fetches what they need. So our performance was working very well. Our developer productivity was going really well because even though the downstreams were REST, we were mapping that all to GraphQL. So the clients or the developers could still explore the REST APIs with the help of GraphQL API. Some questions that a lot of the team members asked us during the adoption process, were that GraphQL is similar to kind of like this graph type database, and because we don't have graph type database, a lot of teams thought that we won't be able to adopt GraphQL or it wouldn't be a right fit. And in fact, we don't need a graph type database. That is a myth. Another myth was that GraphQL is kind of like this query language, which it is not. It's a way of querying for data. And because it was really popularized by JavaScript developers, people thought that GraphQL is only for JavaScript developers, but there are libraries for GraphQL in almost all languages now. A lot of developers had the concerns that all the downstream APIs are in REST, so they'll have to convert all of the endpoints to GraphQL. But actually, you can orchestrate any of the APIs, any of the downstream APIs as GraphQL APIs, even if you don't have control over it. So even if you don't have ownership over the downstream APIs, you can still orchestrate as a GraphQL API. A lot of teams also had a concern that they had sensitive data that they couldn't let users just query whatever they want to. But actually, because you set a contract and you set a schema, so users can only query what you expose. So that way you can control any of your sensitive data. And people asked if they can limit any APIs they are exposed. So, for example, for user A, they only wanted to expose 4 fields, and for user B, they only wanted to expose 1 field. And that is possible as well. You can do that with the help of authorization and authentication. It is still new in GraphQL, and you can use existing authorization and authentication if you have in your company, and that would work just fine. So, with our adoption of GraphQL, here are some lessons that we learned, and here are some mistakes that we made. The biggest advantage I think we had was that we picked our first app, which was kind of like our playground, like our experimentation project, and that gave us a lot of lessons to learn, and that gave us a lot of room to make mistakes. Because it was internal, because it was low visibility, we had a lot of room to learn and grow and take our time. So I think that is a great step if you want to adopt GraphQL, which is pick your first app, which is very low visibility and low stakes. One of the mistakes we made was that because our REST API in our merchants team, because our REST API was built completely new as well, we started doing like this one-to-one mapping of REST with GraphQL. And that kind of sucked because we pretty much duplicated everything that was being done in REST. So we kind of did it twice. And that is a mistake. So don't do a one-to-one mapping of REST and GraphQL, because you're basically duplicating your efforts. You're basically doing everything that Rust is doing just for the sake of converting into GraphQL. Another good thing was build schema together. This helps bring two teams together. It helps to collaborate between the two teams, and it helps to set the schema up front so there are no surprises, and both of the teams can work independently after that contract has been built. Another thing that GraphQL provides out of the box is input types and non-nullable types, which is the type field and exclamation mark that we just saw. And that's really cool because it's kind of like, especially in JavaScript, it's kind of like giving you that validation for free. And if all else fails, orchestrate. Even if you have REST APIs, if you have GraphQL APIs, GraphQL works really well as an orchestration layer. So GraphQL is a great contender for an orchestration API. But it's not all roses. There are some challenges with GraphQL as well. Like we noticed with our merchants API is that it is only as fast as your slowest endpoint. So when you're doing one-to-one mapping, you may be actually like exposing all the data that your REST is sending over. So take a look so GraphQL isn't like a magic solution to your performance needs. So take a look at how slow your APIs are, and how much data you're getting from it. So if you are throwing all the data from your server to the client, and the client doesn't need all of that data, then GraphQL would be a good fit. But if the client needs to use all of that data, then you're not going to gain much with converting it to GraphQL. Some other challenges of GraphQL are it is a new technology, so a lot of things are still being developed. For example, things like authentication and authorization and caching and error mapping, they are not standardized just yet, so they are still being developed. And if you rely heavily on caching and error mapping, you might want to take a look at what your needs are, and maybe GraphQL may not be a good fit for you. Another thing is public versus private GraphQL APIs. There are some companies like Shopify and GitHub that have done public APIs, but actually doing public GraphQL APIs is really hard because you need to set that schema up front. And as a GraphQL API or as a public API, you may not know what your client needs to know, all the data that they may need to know. So doing a GraphQL public API is a hard challenge. Another thing is that, and this is another challenge that we are working with, which is making that one graph when you have a bunch of different repos throughout your enterprise. There are some companies that are now, some libraries that are now helping with making that one like federated graph, such as Apollo Federation and Hasura. So if you are looking to make that one graph that everybody should be able to talk to, take a look at those libraries. So now that we are here, really quickly, what are the next steps for you? So if you want to adopt GraphQL, here are some questions you can ask yourself. For your enterprise, what are the main problems you're having? Who are your API developers and consumers, and how much ownership do you have over the APIs that are being built currently, and who is using these APIs? If you have any company specific tools like authorization or monitoring and analytics, and where do you want to put those? Are those supposed to be client side or server side? Another important thing to note is how are you going to enforce the standards? Do you depend heavily on caching or error mapping? These things are still being developed for GraphQL. So GraphQL may not be a right fit if you depend heavily on them. Um, and if you do want to move forward, set up your enterprise for it. So talk to your domain experts. Do a similar exercise with your company and find out like your first apps. Set up a standards team, and this would be the team that will help in kind of doing that federation, that one graph approach for you, resolving the schema conflicts and help you do schema stitching. And there's tons of libraries out there. So explore what libraries you can use off the bat and what technologies you're using. So are you using are you using JavaScript or or Java or Go? And here are some tips to sell GraphQL to your team. The biggest tip that worked for us was to show people tooling. Once we showed them graphical, their eyes kind of lit up and light bulbs fired. So start with the tooling, start with graphical, start with Playground. Those tools are amazing and they solve a lot of dev problems. Focus on dev productivity, on the exploration of APIs. That works really well for front-end developers, especially. Talk about incremental adoption, that you don't have to pull down everything just to convert them to GraphQL. Talk about the fact that GraphQL doesn't need versions, so your updates are available to the clients as soon as possible, and deprecations can be made a lot more intelligent. Talk about the fact that it is similar to JSON, and that is why it becomes easier to understand the data that is coming back. And get your domain experts and your architects on board as well, so you're not the only person who is talking about the benefits and and challenges of GraphQL. So, final words. I think GraphQL is here to stay. It has made a lot of improvements in the last 2 years, and there's a lot of excitement in the community about GraphQL. So I think you should definitely give it a shot. I think that no API is perfect. REST API has its challenges, and so does GraphQL. A lot of the challenges are being worked on in the GraphQL community. There's a lot of libraries that are being worked on that are helping to solve those challenges. So if you are interested in becoming in adopting GraphQL, get involved in the community. I think the biggest power of GraphQL is the community and the ecosystem that comes with it. And if you're interested in our adoption story and want to read more about it in detail, Mark Stewart from PayPal published a Medium article on a success story for PayPal checkout, which has more details about what I talked about today. And here's a list of other companies, Expedia and Netflix, who have done GraphQL well in public. So again, thank you so much. If you have any GraphQL related questions, feel free to shoot me over at Twitter at ShrutiKapoor08. You can also join my working sessions on Twitch at twitch.tv/ShrutiKapoor. And if you're interested in more GraphQL newsletters or GraphQL and JavaScript tidbits, you can join the newsletter at tinyletter.com/ShrutiKapoor. All the slides from today will be available at my GitHub, github.com/ShrutiKapoor08/talks. I do want to leave with the final dev joke. Thank you so much, everybody.